Device correct.
Hello. Good afternoon, all. Myself, Nivin. I'm from Pantech eLearning. So this will be a session on. So this webinar. In this webinar, we'll be discussing about Internet of Things. So I'm my field of I work in embedded systems. I'm a software embedded developer. So I work on embedded systems. So Internet of Things actually can be part of many different fields of engineering. Actually, it is not just restricted to one particular section. So I am working in embedded. So I have experience with the single board computers and conventional type of microcontrollers and SoC boards. So these are all these are some of the things that are used in Internet of Things. So we'll be talking about Internet of Things throughout this session. So what is Internet of Things in the sense, like if I can give a brief explanation of what is like in Internet of Things in the most basic sense, it is a collection of things that are automated, that are connected to the internet for various purposes. So you all know about like these days automotive, like it is a new era of automation where where there is a lot of research going on right now, and a lot of things are implemented in autonomous car. So a lot of research is going on right now. They have created a standard that all the companies, all the different vendors are coming together to create a new standard for autonomous cars. So in any kind of autonomous vehicle, it is always connected to for safety purpose and different other purposes. It is always connected to the internet. So cars like Tesla, they are always connected to the internet, and the car can actually can link to a server, and it can actually download software on its own without like a Windows updates. Windows will update on its own. If we give automatic updation option, it will periodically update on its own. Same like that, the car software will get updated without even the person knowing, and that will actually improve the performance of the car. Sometimes even the updates can be software updates can increase the speed of the car. Actually, there is a increase the performance of the car because they have found some new something they can do in the software that will change the mechanics in a better way. They can so that type of things are some examples of Internet of Things. And Internet of Things is used in so many places these days. So we'll just go through the history of Internet of Things, history of internet first of all, then Internet of Things, and then we'll see some practical examples too. So internet revolution. So we are all very familiar with internet because we are while growing up, maybe you guys while growing up, or people, we have it's been around for with us for like we have in its popular format for like 15 or more than 15 years in its popular format. But even before that, internet was there. Like from 1969 itself, internet was already there, but it was a different form. It wasn't the internet that we are used to right now. The popular form of internet came to existence afterwards, after early 2000s. So I will just go through the revolution of internet, the history of internet first. Then so Internet of Boffins, that is the first era of internet, that is Internet of Boffins. So Boffins means it's a name used, a synonym used for referring to researchers. So people who are academics, who are doing research, who are doing research in various institutes. So Internet was originally founded by Defense Department of United States of America, USA, Defense Department of USA, and they called it ARPANET initially. ARPA is the research wing of research and development wing of defense Defense Department in US. So actually, in case of defense, the biggest investor of any research, research in any country is government itself, not the private firms, not any private individual or a company. It is the biggest investor of every research in every country is the government itself. So same as that, the Defense Department and the government of US government was interested in like so many different type of research that is going on in different institutes. So you can see there are these prestigious institutes in America called Ivy League colleges, Ivy League universities, like Stanford, Harvard, MIT, or Caltech. These type of institutes are actually they have a very good research wing. So these people are actually not just they're actually researching on different type of practical things that are for the future. So they right now, for example, if you take one biggest development that is going on right now is quantum computing. In quantum computing, in future, it is still in its novice initial period, but in the future we'll be able to use quantum computing and its different technologies involved with it. So right now it is going on as a research. So like anything you take, whatever we have right now, it's always it has been a research one time. So that the US government, what they did was they needed to interconnect all these different institutes. Maybe two institutes are doing the same kind of research. So by linking them together, by linking these two institutes together, they can actually benefit from that. Because the two teams are researching on the same thing, and if they don't have any ways to share the information, if they only have they can only have letter correspondence or fax or those things, that means they only have very limited way of communicating with each other. So if they don't have that type of real-time communication between each other, then the research might not be as fast as it should be. Like if 10 people are working on the same thing and 5 people are here and 5 people are there, that means there is a inefficiency. So to resolve that, US government actually formed this collection of institutes. They formed this collection of networks and they interconnected, like they already had they created local area networks in these institutes to link different systems in the institute, different computers in the institute, and then again they interconnected all the different collections of LAN networks to create a network called ARPANET. So ARPANET was exclusive only for these researchers. Only these people can access, the government officials, defense research teams, and only these researchers, certain universities, researchers were only be able to access the internet at that time. So that was a closed internet. And then then at the late stages of this era, at the early 90s or late 80s, they actually let other people to log in, like not just the researchers from this prestigious institute, but other people who are interested in similar type of research. They can pay a small fee and they can get get some credentials to log into this, and they can read different whatever data that is published, whatever papers that are published. They can read all that. They can get that information. So it was open to some people even at the end of this era. and then after 95, uh, internet became more open. So they made it open, so anyone can connect to internet. Anyone can create websites, and anyone can connect to internet. So we know about, like, right now, if we think about what are the biggest companies in this world, like Amazon is one of the biggest company. They have actually so many different servers. Their main business is not in delivering things. Their main business is actually in servers. They rent servers to different companies, and so many cloud so many cloud services uses Amazon servers. So they have actually started in the early stages of this popular internet. They started the company in 96. Jeff Bezos actually started the company in 96 as a delivery company to deliver different things to people. So actually initially it was just books. They wanted to just deliver books, and then from books they improved that to they included different things, and that is right now we know about Amazon. Whatever there is, they're like the one of the largest retailers in the world. So they started in the early stages of this in popular internet. So even at that time, internet wasn't that popular because PC was expensive, a personal computer was expensive. You need a personal computer to access the internet, and the internet itself was very expensive, and it was very slow. There was not that much use, like people, only enthusiasts, like people who are actually interested in these things like technology and science. They were the only people who were accessing this internet. Not just they weren't the only people. There was also other professionals who used internet for various purposes, but mostly, other than them, mostly these people, so we can call them geeks, or they're like enthusiasts who are interested in things things that most people are not interested in, like technology. And these days most people use technology. They use their phones, they use their computers, and they use internet, they use different type of websites, and government itself uses so many these days so many government portals are automated through internet, and we can easily apply for different things. So everything is done through internet these days, but still people use them because they use, like, person who driving a car may not know anything about mechanics of the car. So the same way they may use it, but still they don't. Most people are not interested in learning about all these things. So this internet of geeks is the era of that era when only these people, like chat rooms. You may have heard about the chat rooms and all these things in the early days, like the predecessor of social media. People like with the similar interests get together, and they interact with each other through chats, and they share different information. So that was a time of internet of that era was called internet of geeks. This was a very short period, like 5 years or less than 5 years, because after that era it was internet of masses, because internet became faster, that people can actually use it for useful, convenient things. They in their life, whatever they have, they can use it for like so many new companies started. We know about the IT boom, and how Bangalore became so much popular after the IT boom, how all these IT jobs were created in India. So IT is a big sector right now. So many companies are Infosys is one of the company that was formed during that day, during those days. And right now Infosys is one of the biggest companies in the world. So this all happened during the time of the early 2000s. The IT boom happened, and so why? Because internet became more faster, so people were able to use, same thing I just said, people were able to use it for different type of things, not just people who are just interested in the technology and things. Other people were able to use it conveniently. And then it became so even at that time still to use internet you need a PC, you need a personal computer. Otherwise, so that was the era of internet cafes. So we, if you're not old enough, you may not remember this time period. In the old times, like not old, not that much old, like 2007, like 2006, 2007, 2008, that time before the mobile internet, before mobile internet, it was time of internet cafes. People would go to internet cafes like on a regular basis for different purposes, like to do like researches or to watch movies or videos or to play video games, whatever it is. They'll go for different purposes to the internet cafes. So that there was so many internet cafes. So these days it is very less because people don't need them. People have a laptop at their hand or they have phone. They don't need anything more than that to use the internet. So still it wasn't that popular because the number of devices connected was less, because only most people were not able to afford these computers. And then came the time of mobile internet. So that that internet of masses is that era with the internet cafes and all that. Then came the time of mobile internet. Then these mobile phones were able to use through cell phones we were able to access internet. Not that much like these days. We could go to Google and maybe even use YouTube, early versions of YouTube. But there was no there was Facebook, and WhatsApp wasn't still in existence. And so that was the time of mobile internet. So with the mobile internet, what happened is mobile is more affordable. It is not to set up a PC you need at least like 20,000, 20 to 30,000 depending on the type of system that you want to buy. Like even if it is a minimum average system, still you need to spend like more than 20,000 to set up a PC. And internet connection, it's also expensive. Then, but with a mobile phone, you can buy a mobile phone for less than 10,000, and you can access the internet with the same SIM card you have. You can access 2G or 3G network. Using that network, you can access in internet. So it was not exactly like the smartphones that we use these days. It was more limited. But it made internet more popular. The number of devices connected was increased exponentially afterwards. Then comes the era of Internet of Things beyond 2012. So 2012 is like the time where new mobile phones, new things were so many new technologies were introduced. Like the smartphones became so much popular. And people were able to use the internet so easily. So that is the era of Internet of Things. That's when the era of Internet of Things started. Like more devices got connected. So we'll discuss about the number of devices and the correlation between the number of devices and emergence of Internet of Things. So why internet? So like for obvious reasons, these are the anytime, anywhere, any person, any business, any device, any network. So then internet, this is just a brief definition of what is internet. No one owns it. There is no formal organization, management, nothing. There is no ownership to internet. It is a public thing. And as it was originally, so anyone can connect to it, connect a local network to the internet. As it was originally developed by Department of Defense, this lack of centralization made it less vulnerable to wartime or terrorist attacks. So it is whenever there is less centralization, it is easy to keep the thing more stable, because centralization means you just have to target one point, then the whole thing will collapse. So that is a the advantage of using these days. We know about cryptocurrencies. So that is one advantage of using cryptocurrencies, because the banking system in cryptocurrencies are not centralized. So it is not possible to manipulate it. It is not possible to hack into it. So because it is decentralized, so the lack of centralization made it less vulnerable to wartime or terrorist attacks. To access internet, an existing network need to pay a small registration. So any existing local network can connect to internet and agree to a certain standards based on TCP/IP. So they have to set up their network in a way that you agree to these network protocols, TCP/IP. So if you study networking, you can learn about all these different type of protocols. So we'll go through some maybe so two of the basic, one of the most basic protocol is IP protocol. Everything is built on the IP protocol. Everything else is built on the IP protocol. And TCP, then there is UDP, HTTP. So HTTP, MQTT, these are all like SMTP. These are all application layer protocols. These are the protocols that we directly deal with. We through our while we are accessing the internet through Google Chrome, we use HTTP protocol to connect with the different servers. So on the application layer level, we use these protocols, and on more basic level, IP is used. Then the person who coined the term, Kevin Ashton. Kevin Ashton is the person who proposed the term Internet of Things. So he was a computer scientist, computer engineer at that time, and Internet of Things. So this is like a definition of Internet of Things, brief definition of Internet of Things. Internet of Things is the network of physical objects, devices, vehicles and buildings, other items embedded with the electronics, software, sensors, and network connectivity that enables these objects to collect data. So it is a collection of physical objects. So objects can be anything. It can be a vehicle, a building, or an appliance at your home, or your laptop itself, whatever your PC. But it can be any one of these things. So, but if you take a thing like vehicle, for example, a car itself cannot connect to internet because it is a mechanical machine. It doesn't have any capability to connect to internet. So we need to embed it with some electronics, some hardware that can access a network, and then it can do some automated things, like, for example, the same example that I explained before. Like in Tesla car, the car can actually connect to internet, and it can download its software updates on its own without the person knowing it, and that can actually improve the performance of the car itself. So embedded with the electronics, so it needs to be embedded with some electronics devices, and software and sensors. Network connectivity enables these objects to collect and exchange data. So that is the purpose of internet here, because we are through internet, everything is interconnected, every place and everywhere. Not actually every place. Still there are so many places that doesn't have internet. For example, if you take a country like Cuba, they don't have the popular version of internet that we have here. Or a country like North Korea, or some deep places in Amazon forest. So these places are not still, they don't have internet access, but still wherever there is more people, we are able to access. And like new technology like the Starlink device. Starlink actually, through Starlink you can actually connect to internet. It is satellite internet, so you can connect to internet from anywhere, like wherever there is coverage, you can connect from there. You don't need a wired connection. So these days, normally most popular version of internet these days is through wires. So it uses wires for connecting to, like, actually internet is connected throughout the world through wires. So there is like international cables that going in the oceans, and there is like a team that is continuously working all the time. You can watch like Nat Geo documentaries about these cable cable laying ships. They're continuously working all the time. Whenever there is a connection, whenever there is a faulty cable, they'll change that. Or periodically they'll change the cables. They lay the cables, and because of different type of reasons, there might be some kind of damage. So they'll inspect that all the time. So there is a whole industry that is based on interconnection. So this whole currently the internet is totally based on these wired connections, but but with the devices like Starlink, you can actually connect to internet without any wired connections. You can directly connect it using a satellite receiver. So that is a very advantageous thing, because you can use internet from anywhere. Like you can go to a forest if you're a researcher for some purpose, and you can go to a forest and you can use internet from there. So that is that anything anywhere, that is still not fully possible, but to a level we can access anywhere. So whole world in one hand. Mission to mission communication. So mission to mission communication is one of the most important things in Internet of Things. So the basic idea of Internet of Things is, without any humans, the machine should be able to do whatever work it is doing. It should be able to do it without any human help. So we should be initially the person should programmer should program the device, and then it should be able to do whatever work it is supposed to do, like exchanging data. Basically, whatever we are doing, it is exchanging of data. Like whether we are collecting data from a sensor and sending it to another node, or we are controlling something from some remote place, or like depending on whether like you can connect to a cloud network, a weather cloud, and get weather updates and forecast on a daily basis, and without any human help, the thing can actually, like for example, like solar farms, where when there is only when there is strong sunlight, it can get the optimum full power output. So when there is it is better to predict when there is no power, like so that type of things we can easily automate using Internet of Things. And everywhere, like electricity. So on campus example, so this is an example of Internet of Things on campus. So in this example, it shows a college or a school campus, but you can implement this in any kind of campus. You can use it in a industrial campus, IT park, or wherever it is. You can do the same thing. Smart Internet of Things. So these are like some of the things that you can implement there. Like for example, if you look at the bottom part here, sensor track buses and verify student passengers. So like primary students, maybe not needed for like higher standard students, but for primary students who are 5 years or 5 to 8 or 9 years, the parents should be able to know where they are, like all the time, or not all the time. Like once the school is done, once the classes are done, then they should be able to verify whether the child has entered the bus, or where is the bus. So this should be they should make them feel less worried where the child is. So using this type of bus tracking, the parents can easily track the students. Then different type of things like personalized learning with the adaptive textbooks, digital classroom whiteboards and displays, iBeacons, and so iBeacons are for like localization and sensor trash or receptacles, sensors on trash or receptacles. So robot cleaning robot, online testing, and student device, e-textbooks, notebooks, and so attendance things. You can automate the attendance, Wi-Fi sensors and logs, entrances are exits, classroom doors. So the entrance surveillance security systems. So like so many examples are here in this one scenario. In campus itself, you can have this many different ways in which you can use Internet of Things. So variable for like these are like some of the examples. Then so the main reason why Internet of Things emerged is because the number of devices connected. So I'll show you a graph, a diagrammatic representation of number of devices connected and population. So from this we can deduce that what is the reason why this technology called Internet of Things has emerged. So here you can see 2003 number of world population is 6.3 billion. So at the same time number of devices connected to internet was 500 million. So that it was fairly less, much less than the world population. And then in just 7 years, world population just increased 0.3 billion, 300 million. But the number of connected devices increased to 12.5 billion from just 500 million, half billion to 12.5 billion. So that is so from here you can see for every single person there is 2 devices connected to the internet. Less than 2 devices connected to the to the internet. So from this we know that even if all the people are using internet, that is still not the case in the world. Even if all the people are using the internet, still every person has to use 2 devices to 2 devices to meet this here. 12.5 billion devices are connected, and then 25 billion devices are connected in just 5 years. Again 25 billion devices connected, so population increased to 7.2 billion. And then in 2020 7.6 billion devices connected, 7.6 billion population, and then 50 billion devices connected. So you can see how many times it is bigger, the number of devices connected. So this is one of the reasons why the Internet of Things technology emerged, because it became that the devices became more smart, that we were able to automate these devices, and they were able to change their behavior based on the environment. So it became essential these devices need to be connected to internet. They need to be connected to internet for various purposes. So that is the reason why Internet of Things, one of the major reasons why Internet of Things, the number of devices, connected devices. So this is like a ratio of each time, what is the ratio of this ratio, 50 by this population, number of connected devices divided by world population, 6.58, you can see 3.47, 1.84, 0.08. So then this is a hype cycle, so different times and peak of different technologies. So here you can see in Internet of Things, peak of inflated expectations. Then this is like a layered representation of Internet of Things. Here you can see at the top level, people and process. So whatever we do, like even if the whole devices are automated, except for some cases, most of the technology, whatever we make, it is always for humans, to make our life more convenient, to make it is easier to consume less time in different things. So it is for coming to making us more connected, so to improve our life, the quality of life. That is the main reason of any kind of technological inventions. So always the end user is always a person or a process. So even the process is the end user, still that a person or group of people benefit from that process. So it is not the case in all the inventions, technologies. Some technologies are invented to solely to just save the environment, to keep the nature as it is. So much research is going on in that level, but it is not it is only a fraction of actual research that is going on, because it is an era of consumer era. It is a consumer era, so whatever is made that is for the people, for them to consume. So they so most of the research is, so to make money, the corporations have to point in that direction. They have to make more things that people can use. So that at the end it is always people. And then applications. So application custom app built using thing data. So custom apps. So an example I can say here is like we can create one example in Internet of Things. Actually, you can do it yourself. If you have the essential knowledge, you can make an application yourself. An application to update your grocery list whenever you need. Like most people make their purchases on a weekly basis. So they'll buy whatever for week and maybe monthly basis. Some essentials we buy monthly basis, but most things we buy sometimes on a daily basis and sometimes weekly basis. So we can make a grocery list, and this is actually we can make it as a application, a mobile application. And through this mobile application you can update, and you can check for whatever you need at a time. So you can create a REST API. You can create an application programming interface. Using a REST API. That is called a REST API. You can create a REST API and you can deploy that in a place like Amazon Web Service, AWS. You can deploy that in AWS, and then you can link and then you can create a SDK application, an Android application, and using this Android application you can access the AWS cloud, and you can update the grocery from your laptop or from the mobile application itself, and then whenever you want you can just check whatever things you need. And we can even make it automated. Like you can have a refrigerator system with the sensors and cameras, and you can like detect. So these days deep learning is very much improved. You can easily, most of the things related to deep learning is open source, like PyTorch, TensorFlow. These frameworks have improved so much. Even a novice person can easily learn that, and they can train their own data, custom data. So there are things like Google Colab that actually provide, Google Colab or AWS that actually, Google Colab is very helpful actually. It provides a free system with the GPU and CPU support. We may not be able to train this data using our local system, because we may not have the kind of GPU in our system or the CPU in our system. So we need we can use open source free services like Google Colab. Using Google Colab you can upload your data, you can upload your training data set to the Google Colab, and you can run your code, the training code, and you can train your data. Even if you have 10,000 data set, you can still train it using Google Colab. So deep learning is actually improved so much these days. Anyone can use it. So you can easily create an application, deep learning application, where it is able to detect different vegetables and fruits and packaged food, different type of ingredients that are in package. So you can train for all these products and fruits and vegetables, and also you can train it for ripe detection. So only one thing you need to do is, normally the light inside the refrigerator will be off, so that you need a lighting system inside, so the camera can detect all these things. And whenever there is something is missing, it will automatically update this thing too. Or something is missing, or it is not sufficient enough, then we can individually count vegetables or whatever it is. And if it is not there, if it is missing, or if it is not sufficient, then it will automatically update to this API, update that particular list, that item to the API. So then you can easily see that on your phone. So that is one example of an application in which you can use in Internet of Things. Then data analysis. So reporting, mining, machine learning, all these things are like data analysis is very helpful. Internet of Things is very helpful for that, because we can interconnect. For example, like an example of data analysis can be like a data collection system in a river. For example, you want to monitor the river water to see if it is polluted, or not. So using different kind of sensors like dissolved oxygen sensor and other like a turbidity sensor. So different type of like elements can be detected through different type of sensors, and these sensors will be connected to a SoC. It can be a SoC or a single board computer or a conventional microcontroller with a in like Wi-Fi module or a LAN module or something like that. Then it will connect to a network, and these sensors can continuously send the data to microcontroller or the device that we have, and then the device in turn will connect to a network, and it can send that to a cloud. And from the cloud, any person can manually download the data, or we can automate that too. Like if we take clouds like AWS or ThinkSpeak, you can actually deploy your own machine learning application in these devices, in these clouds. Actually, you can program the cloud, and then automatically you can link that to your data stream. So by the program will be running continuously, and at the same time the data will be updated every day. So the whole thing is automated in that case. Then big data harvest, storage of things. So there is data ingestion. Like these days we know about the personalized ads. Based on our needs, we'll see ads of different kinds. So that is the meaning of big data. So that's where the things like big data comes into play, and all these things are automated. Then global infrastructure, different type of global infrastructure, like cloud infrastructure, private, hybrid, managed. So different type of cloud infrastructure. So we know about so many cloud services these days: Google Clouds, AWS, ThinkSpeak, like so many different cloud interfaces and APIs are there. You can easily use them. So many of them are free. You can research them. But when you go into like when you go into using them for a financial financial purpose, then you may have to purchase it. Otherwise, you can use it for any kind of prototyping or research purpose. You can use them for free. Then connectivity, edge computing, like different type of networks, connectivity, protocols, mission-to-mission, Wi-Fi, telecoms, hardware kits. All these things comes under connectivity and edge computing. Then things itself. So things are at the lowest level. Things like whatever things that can be connected to internet, like cars or buildings or different appliances, anything that can be connected to the internet. So things, examples of things in a home scenario, whatever we have like limitless number of options are there for in home scenarios. We can like then in basic sense, like in the Internet of Things these days, if you study Internet of Things itself, you may be mostly interested in hardware based Internet of Things, where you are able to interface different type of sensors and actuators, and then they can communicate with each other for different purposes. For any kind of examples that I've said here, like the refrigerator example or the river water pollution monitoring example. So that one advantage of that project is you can predict using, again you can give that data to a machine learning program, and using that machine learning program we can predict whether this will cause some kind of health issues for the people if they use the water, or you can predict whether it is going to be used is going to cause any problems for the underwater animal population, like all the fishes and all the other amphibians and different kind of creatures that live in water. If there is any problem with that, like where less oxygen content in any water means that actually directly affects the fauna and flora population of underwater systems. So that is, yeah, we can predict that all. So sensors are very essential in that case. So this is like a brief definition of what is a sensor. A sensor is a device that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument. So it is a device that can measure a physical quantity and then convert it into a signal, an electrical signal. So like example, if we take an example, it is I can talk about this sensor called LM35. It is a temperature sensor actually. It's only based on so you have I think you're all studying engineering or technical some technical course. You're doing some bachelor's or maybe in technical, right? So here so you may have already studied about electronics and semiconductors. So one of the main characteristics of semiconductor is that it is susceptible to different type of external factors like magnetic fields or temperature. So it is susceptible to temperature. Like almost all of the electronics things are made with the silicon. So the chips are all made with the silicon transistors. So many devices are made with silicon, and silicon is a semiconductor that is highly susceptible to temperature. We can actually engineer it not to be that much susceptible, but in some cases we need it to be susceptible because the like in the example of a temperature sensor LM35, it is actually it uses that principle of a semiconductor being susceptible to temperature to measure the atmospheric temperature. So it can based on the temperature, the current flowing through. So it is actually, if you search yourself in internet, you can find the image of LM35. It looks like a transistor, and it is a transistor. It has 3 legs and base, collector, emitter, similar like that. And the middle pin you can connect. Middle pin is the sensor output. So when you increase the temperature, surrounding temperature, or if you put the sensor in introduce some kind of hot object to the sensor, then the temperature will increase, the current flow through the sensor will increase. So there is a direct correlation between the degree of increase and the increase in current voltage, So using that increase in voltage and the degree increase, you can easily calculate the temperature, current temperature. So that is an example of a sensor, how a sensor can so different sensors have different type of mechanisms using which they convert the physical parameter into an electrical signal. So different type of sensors, water level sensor, it uses one type of mechanism. It uses a rotor mechanism to count the number of rotation, and this area is fixed. So this inside there is a rotor that will continuously rotate when any fluid is flowing through it. And then LDR sensor, it is a resistor, light dependent resistor, and analog sound sensor, and current sensors, electricity, two type of current sensors. Then the sensors there are 2 type of sensors, discrete and proportional sensors. And discrete means digital sensor, proportional means analog sensors. Then controllers and devices gathers data from different controllers. So we have already discussed. So we can use any kind of SoCs like Raspberry Pi are used these days. Not exactly Raspberry Pi. Raspberry Pi is more a student study purpose type of device. And Arduino is a prototyping device. You cannot learn that much about embedded system by using Arduino, but you can easily program it. If you are in a school level or in a college level, you don't have that much knowledge about the architecture and programming, like basic level embedded programming. You can't write your own drivers and firmware and all those things. Then you can easily use boards like Arduino boards to make your own prototypes. So, and also Arduinos are used in, not exactly Arduino Uno, Arduinos are used in different type of industrial cases too. Different products are developed around Arduino devices and programmed through Arduino. One disadvantage of Arduino is that it is slower than a conventional microcontroller because it has so much overhead because of all the libraries, all the packages, all the drivers that are there to support the Arduino. Then cloud device, different type of cloud, we have already seen all these. And safety and security purposes, car safety and security purposes, face recognition, sleep detection, so like stop sign recognition. So these type of things can be, obstacle stop sign can be integrated with the car and connected cars, interconnected cars to avoid accidents and different scenarios. Certain traffic monitoring, like traffic density monitoring and automated traffic systems. Car parking systems, these are another example of Internet of Things. This is a simple setup here with the ultrasonic sensors. You can detect the vehicles using ultrasonic sensors, or you can use camera or IR sensors or any other kind of sensor or weight sensor to detect the car. Smart home, umbrella that can predict weather patterns. Things with the social network, you can connect your single board computer to any social network like WhatsApp or Telegram. Greenhouses, so sensor data, live streaming, smartwatches. These are some examples of this thing. So I hope the session was useful for you guys. So this is it. Like, this is a brief introduction into the Internet of Things. We haven't seen any practical side here. We don't have the time for that. So you can do it. You can do your own research. It is very easy. You can find your own different type of tutorials. You can use Arduino type of platforms like Arduino. You can easily learn Python programming, and you can use our own learning platform. You can use Pantech learning platform to learn about all these things. You don't have to do it yourself. You can if it is always easy when there is a person to explain things to you. So you can use our own learning platform to learn about these things, and you can make them useful for your career. So thank you everyone for listening. So it is our time. It's already 4:05. So I think we have to wind up the session now.